and the result shows that nanocellulose
Hello, doctor. You asked for the video and audio. Dr. Yasmin.
Hi, Afrin.
Hi, Assalamualaikum.
Waalaikumsalam. Afrin,
Yes.
where's the others?
Still joining because the stage session only still question answer going on.
Oh, no wonder. I don't know why suddenly he logged out. I mean, it suddenly refreshed by its own. I just afraid.
One more day with this trouble.
Huh? Is
One
it?
more day only.
That's the thing. I afraid tomorrow we have a stage presentation for technical talk. It happen like this, then gone.
No. Stage looks good.
Ah,
Parallel sessions.
oh,
Assalamualaikum. Hello, Dr. Chi. Can you can you ask for audio and video? Because maybe for photo session, you have to be on the screen. Dr. Mimi Hani Abubakar also, can you please ask for audio and video? Assalamualaikum. Our chair session is already.
Can you guys hear me?
Yes.
Yeah.
Now okay, Dr. Yasmin?
yeah. I think it's being refreshed. Hopefully, it will be okay.
Inshallah.
Okay, can we? Is everybody here?
Yes, doctor. We will be doing.
Good. I think we already nine. Okay.
Do you hear an echo?
Bismillahirrahmanirrahim.
Oh, right?
There's an echo, right? Is it coming from me? Is it clear now?
Yes.
Okay. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon to everyone. Welcome to the International Conference on Nanotechnology and Catalysis MICNC 2021. We are now in the session 3, Biofuel, Biomass and Biodiesel. So my name is Liza Yusof and I'm a postdoctoral research fellow Nanotech, University Malaya. I will be your session chair today with our IT moderator, Madam Afrin Jahan and Madam Suzaimi Johari. So, we are about to begin at 3:40 p.m. Stand by. But before that, I would like to seek for your kind cooperation to avoid any disturbance during the live broadcast session. If we have any question, the conference IT personnel are ready to attend you. Before we start, let me briefly explain about the oral presentation will be awarded under two categories. First, best session presenter that will receive the certificate for best presenter that will be announced at the end of the session. Second is best presenter award that offered money from 500 to 1,000 with trophy and award certificate. This will be announced during ceremony on the last day. Again, I will seek for your kind cooperation to mute your microphone, your mic if you are not presenting, and to avoid any virtual disturbance. For those who intend to ask questions, you can channel in the chat box or in the Q&A box. I will read the question after each presentation. You also can request to share audio and visual if you want to ask in the live mode. For presenters, you are given 15 minutes for presentations for Q&A session, while for the invited speakers are given 25 minutes for presentation with 5-minute Q&A. Our moderator will remind the presenter to end the session 2 minutes before the session ends, and I will start the presentation when the session already exceeds the 5 minutes allowed. Before we start the session, appreciate everyone to turn on camera to get a photo session.
You call Dr. Chi.
We need to wait, Dr. Chi.
Chi is here.
Okay, maybe we can.
Dr. Chi, can you come to the screen? Just ask for audio and video. Also, Mr. Tiku and Mr. Nihal is here. Okay, we proceed because they have some network problems.
It's okay. I think maybe we can take another photo session at the end of this this session. Maybe we can take first here, once here, and then after. Okay. Okay. Next on two. Smart. Okay. Done. Okay. Thank you. The rest will start in the next session. Okay. I think now we already at 3:40 p.m. And without further delay, I would like to invite our first speaker, Mr. Teguh Rianto. He will present on his topic, palm oil conversion to hydrocarbon-rich biofuel over CO and MO modified ZSM5 catalyst. Please welcome. The floor is yours.
Okay, thank you. First, I think I've contacted the IT committee. Could you please play my video, my pre-recorded video? Thank you.
And heard also?
It is visible, but the sound, we can't hear the sound.
Oh, sorry.
Bismillahirrahmanirrahim.
Now,
Assalamualaikum warahmatullahi wabarakatuh, and a very good day, everyone. My name is Teguh Rianto from Universitas Diponegoro, Indonesia. It is a great pleasure to be here to present my research entitled Palm Oil Conversion to Hydrocarbon-Rich Biofuels over Cobalt and Molybdenum Modified ZSM5 Catalyst. So this is the outline of my presentation today. The first is introduction, materials and method, results and discussion, and then conclusion. Okay, we know that we are facing a global issue, which is the energy demand is going to increase, but the fossil fuels as the main energy demand to supply the main energy resource to supply the energy demand is going to decrease. Therefore, we have to find to develop a new energy that can supply the energy demand, or at least can support the fossil fuels to supply the energy demand. And biofuel appears as a promising fuels that can supply the energy demand, or at least can support the fossil fuels to supply the energy demand, because biofuel has a similar characteristic to fossil fuels. However, biofuel is environmentally friendly because it doesn't have pollutants such as sulfur and nitrogen that can easily be found in fossil fuels. On the other hand, biofuel is a renewable energy because it is produced through the biomass conversion. Since the biomass is still present, biofuels still can be produced. And the most developed biofuel is palm oil-based biofuels through catalytic cracking, because palm oil is abundantly available in the world, especially in Indonesia and Malaysia. And the main compounds of in the biofuels from palm oil conversion is hydrocarbons and oxygenated compounds. However, the oxygenated compound should be avoided because it can reduce the heat capacity as well as the heating value of the biofuels. And the composition of hydrocarbon and oxygenated compounds are highly affected by the catalyst used. Therefore, it is necessary to develop a catalyst that can support both cracking and deoxygenation reaction simultaneously. And the most developed catalyst is zeolite-based catalyst, because zeolite has a high surface area, which is important in the catalytic cracking to reduce. They can reduce the mass transfer limitation. Furthermore, it is necessary to develop ZSM5-based catalyst, as reported by Gurdeep et al. At 2020. They reported that ZSM5 catalysts are effective to produce hydrocarbon-rich biofuels, especially in the range of biogasoline. However, ZSM5 catalysts produce aromatic compounds. Even though these aromatic compounds can increase the octane number of biogasoline, it should be limited because they can be released to the environment as the toxic compounds such as benzene, toluene, and xylene. Therefore, it is necessary to modify the ZSM5 catalyst before it is used to convert palm oil to biofuels. And metal impregnation can be used to modify the ZSM5 catalyst. However, we have to choose the metals that can support the deoxygenation reaction as well as the low aromatization reaction. Okay, as reported by study at all, the cobalt has high activity in the oxygenation reaction. On the other hand, molybdenum also reported that it could increase the hydrocarbon compounds and aromatic compounds. However, Haji Morning et al. At 2021 reported that molybdenum impregnation on ZSM5 could decrease the aromatic compounds. Therefore, it is a contrary. So, in this study, we investigate the effect of cobalt and molybdenum impregnation on ZSM5 catalyst on the PL ratio and the performance of catalyst for palm oil cracking to produce hydrocarbon-rich biofuels. So the catalysts were synthesized using wet impregnation methods, and this schematic diagram represents the steps in the laboratory. The obtained catalysts were characterized using several methods, such as XRD to investigate the crystal structure, SEM to investigate the surface morphology of the catalyst, and BAT to determine the surface area of the catalyst, and pyridine probe FTIR to investigate or to determine the acid types, the types of acid site and the acid site amount. The catalyst performance test was conducted in a fixed bed catalytic reactor for palm oil cracking to biofuels. The liquid product were collected and the composition of the liquid product were determined using GCMS analysis. The yield of the product were calculated using this equation. Okay, we are moving to the results and discussion. Okay, based on the XRD patterns, it can be seen that the catalyst exhibit the characteristic deflection of MFI structure due to the appearance of quintet peaks at 2 theta between 23 to 25 degrees. We also found that the relative crystallinity of the catalyst decreased after metal impregnation. However, the crystal structure of the catalyst is not significantly changed because it can be seen that the XRD patterns are not significantly changed after metal impregnation. Therefore, it is reasonable to conclude that the decrease in the relative crystallinity is attributed to the coverage of metal species on the catalyst surface instead of the framework destruction. Concerning to the metals that impregnated on the catalyst, the peaks corresponding to the metals are not found. It can be concluded that the metals are highly dispersed on the catalyst. It is proven by the SEM analysis that it can be seen that the surface appearance of ZSM5 catalyst and cobalt molybdenum ZSM5 catalyst are not different. Okay. As can be seen that the surface area of the catalyst decreased after metal impregnation. It can be concluded that the impregnation of cobalt and molybdenum on ZSM5 catalyst can partially block the pores and reducing the catalyst surface area. The metals on the surface on the catalyst partially block the pores or the pore mouth of the catalyst. So the catalyst surface area decreased after metal impregnation. And based on the FTIR, the pyridine probe FTIR analysis, it can be seen that the peaks corresponding to the Brunset and the Lewis acid sites are both found. It indicates that the catalysts have both Brunset and Lewis acid site. However, the composition of these acid sites are highly affected by the metal impregnation. As can be seen that the cobalt and that the metal impregnation can increase the Lewis acid site, and as the result, the BL ratio decreased after metal impregnation. However, the co-impregnation of cobalt and molybdenum decreased the Lewis acid site, as well as the acid site at the total acid site. And as the result, the BL ratio increased after co-impregnation of cobalt and molybdenum on ZSM5 catalyst. It might be caused by the formation of cobalt molybdenum oxide metal cluster or the formation of inactive species as reported by several researchers. Okay, concerning the catalyst activity, it can be seen that the product distribution is highly affected by the catalyst properties. And based on this result and the catalyst characterizations, it can be concluded that boron acid site is responsible for the cracking reaction. And concerning to the coke formation as the deactivation agent, it can be seen that the coke amount is in line with the Lewis acid site amount on the catalyst. So it can be concluded that the Lewis acid site is the active site for the coke formation. And it can be seen that the hydrocarbon is the highest component in the liquid product. It can be it is suggested that the hydrocarbon is produced through the deoxygenation reaction. And based on this result, we can conclude that the catalysts are highly reactive in the deoxygenation reaction. And as can be seen that the hydrocarbon composition increase after metal impregnation. So it can be concluded that the modification can increase the catalyst activity in producing the hydrocarbon-rich biofuels. As can be seen that the hydrocarbon composition is seems to be in line with the Lewis acid site amount. Therefore, it can be concluded that the Lewis acid site is also responsible for the oxygenation reaction. On the other hand, alcohols appears that indicates that the hydrogenation of fatty acids are also occurred during the cracking reaction. Okay, as explained before, that the hydrocarbon are produced through the deoxygenation reaction of fatty acid in the palm oil. However, the deoxygenation of palm oil should produce only C15 and C11, C17 because the fatty acid on the palm oil is the main fatty acid in the palm oil is palmitic acid and oleic acid, which has carbon number of 16 and 18. However, it can be seen that the highest hydrocarbon range in the liquid product is in the range of gasoline or under C or below C11. However, the hydrocarbon distribution produced by the cobalt and molybdenum ZSM5 catalyst is different. It can be seen that the hydrocarbon of cobalt and molybdenum ZSM5 catalysts are highly dispersed. It is due to the low acid site. On the other hand, it can be seen that the catalysts are highly have a high affinity to the cyclization reaction, which is indicated by the appearance of cyclic hydrocarbons. And also, the catalyst has high activity or high affinity in to the dehydrogenation and aromatization reaction. As can be seen that the ratio of olefin to paraffin are high enough, but the cobalt and the combination of cobalt molybdenum ZSM5 catalyst has the relative lowest ratio. It indicates that the co-impregnation of cobalt and molybdenum on the ZSM5 catalyst could decrease the dehydrogenation and aromatization reaction. Okay, we are moving to the conclusion. As the conclusion, the impregnation of cobalt and molybdenum on ZSM5 catalyst decreased the relative crystallinity and the surface area of the catalyst. The Lewis acid site was increased and PL ratio was decreased by the impregnation of cobalt and molybdenum. However, the co-impregnation of cobalt and molybdenum decreased the Lewis acid site as well as the total acid site and increased the PL ratio due to the formation of cobalt molybdenum oxide metal luster and or the inactive species. The cobalt and molybdenum modification increased the catalyst activity to produce hydrocarbon-rich biofuels. And the co-impregnation of cobalt and molybdenum to ZSM5 catalyst changed the hydrocarbon distribution so that the hydrocarbon products were not only gasoline fraction but also kerosene fraction. In addition, the co-impregnation of cobalt and molybdenum to ZSM5 catalyst decreased the acidity so that the coke formation decreased. This property is expected to increase the catalyst lifetime due to the low deactivation by coke. Okay, in this opportunity, we would like to thank the research institution and community service Universitas Diponegoro or Lembaga Penelitian dan Pengabdian kepada Masyarakat Universitas Diponegoro for the financial support through the research project of the World Class Research Universitas Diponegoro. In this opportunity, we also would like to invite you all to visit our international journal, Bulletin of Chemical Reaction Engineering and Catalysis, on website at pcrec.id, and on Twitter at pcrec_J. We are also inviting you to follow our research center, Laboratory of Plasma Catalysis, on Twitter at Plasma Catalysis. So that's all from me. Thank you for your attention and have a nice day. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to Mr. Teguh Rianto for your great presentation. I think now we open for the Q&A. So any question for our audience, or maybe you can chat live. Any questions? Okay. Maybe I just want to ask. You mentioned about the lifetime of. What is the any specific characteristic that you can use to measure the lifetime of your material?
Sorry, your voice is not clearly. Could you repeat your question?
No, I just want to know that you believe that your material can increase the lifetime
Oh yes.
of application. Maybe you can explain further how it can improve the durability of your materials.
Okay, thank you for your question. It is just suspected because we didn't conduct the stability test of the catalyst, we suspect that the low coke formation could increase the lifetime of the catalyst, because the main deactivation agent of the catalytic cracking for the catalyst is coke formation. I think that.
Okay, thank you. There is another question, okay, from Madam Suzaini. Thank you for your presentation. I have a question. You mentioned Lewis acid site is responsible for your catalytic activity. May I know how it works?
Okay, thank you for your question. Sorry. Okay, thank you for your question, Dr. Suzaimi. Okay, I mentioned that the Lewis acid site is responsible for the catalytic cracking because, as we know, that the Lewis acid site can accept the electron pairs from the reactant, and this process can initiate the catalytic cracking, because when the reactant is chemically absorbed on the Lewis acid side, it can easily be cracked. I think that.
Okay. Okay, thank you. Any other questions from the floor? I think no. No other question.
No other.
So,
Okay.
any?
No.
So thank you. Maybe we can move.
Thank you so much.
Okay, thank you. So now moving along to our next presenter, Dr. Mimihani binti Abu Bakar from the Institute of Fuel Cell, Universiti Kebangsaan Malaysia. Her presentation will be on the aerodynamic modification performance in air-catered microbial fuel cells. Please welcome her.
Oh, I cannot hear the sound.
Assalamualaikum and good day everyone. I'm Nihani from Institute of Software University
now?
Kebangsaan Malaysia. We'll be sharing with you work
Good.
done
Thank you.
by our student, Mr. Samuel Reinhard Ignatius Torres, with the collaboration with College Kemahiran Tinggi Mara, Masjid Tanah Melaka, on his work titled Performance of the Immobilized Aryl Diazonium and Agarose Gel Modified Anode in Aic Test Microbiofuel Cell. The aim of this talk and his project is actually to see the effect of combining both the aryl diazonium and agarose gel anode modification for overall performance of the microbiofuel cell. For introduction, why is this technology? Why microbiofuel cell? This is because of the advantages that microbiofuel cell brings, which is itself a renewable bioelectricity energy. It can convert organic matters in wastewater, example, domestic wastewater, swine, wastewater, leachate, and urine to electricity, and it operates at ambient temperature. Why is it single chamber? Because most of the time you're going to be seeing dual chamber. It's because single chamber is easier to scale up, and since we only use the oxygen from the surroundings, so it's going to be less in cost. Why aryl diazonium as modifier? Okay, it's because it's important to have good biofilm on anode. The aryl diazonium itself is positive charge, while the most of the bacteria that we want is negative charge. So it's going to be very good connection between them. Common material used for anode would be carbon-based, and aryl diazonium was mentioned to be able to create stable bond with carbon with positive surface charge. And why agarose gel as immobilizer? Because to maintain suitable electrochemical bacteria is very crucial. Therefore, if we able to encapsulate the good bacteria, which is the electrochemical microorganism, onto the anode and maintain it that way, it might give us some good on the power performance. The methodology used here have been categorized into several categories: electrodes, reactor, operation, and analysis. For the electrodes, we focus on the anode and cathode. Anode, we use in-house graphite brush for the inside of the compartment of the reactor, while as for the cathode, we use our in-house 20% platinum carbon black on carbon cloth. So for the anode, what happened is that there's two steps in it. The first treatment we did was we modified the anode with aryl diazonium, and on several particulars here on how we made it. And after a month or so, when we reach the suitable voltage that we want, we're going to have the anode itself immobilized with agarose gel. And this is the particulars, the method that we used. As for the cathode, we just used a carbon cloth, plain carbon cloth, and we smeared it with 30% platinum carbon black. The reactor, we made it ourselves with using porcelain. We made an in-house tubular single-chamber air-gathered fabrication using porcelain, using Autodesk Inventor, and 3D printing clayware in the Masjid Tanah Mara. The operation that we've done, the analyte that we used, we took mud from the lake to become our microorganism, and the feed going to be the sodium acetate and BBS. To make a closed circuit, the monitoring, recording of power performance, we use a Kinetic external resistor. Batch feeding, every time the voltage dropped to 20 millivolt, immobilization, as I mentioned just now, when the voltage system reached 250 millivolt, then we take it out, the anode, and we dipped it inside the agarose gel. As mentioned earlier, the electrodes, there's set A, treatment, the modified anode, and set B, control. For the first one with the modified diazonium, our control is the unmodified anode, and when we have the immobilized anode, our control was the immobilized, unimmobilized and modified anode. This is unimmobilized, sorry. Okay. So we're going to discuss it in the analysis. We're going to discuss it in 5 categories, which is on the electrochemical analysis using linear state potentiometry, the internal resistance using the electrochemical impedance spectroscopy, on the pH and chemical oxygen demand, the coulombic efficiency, and the morphology and element on surface. So let's go for the electrochemical analysis. We on the first month we monitor the system on the first month, second month, and the third month. The first month, the process was done on the modified Microbiofuel Cell, and the second month and third month is when we use immobilized anode in our Microbiofuel Cell system. So in the first month, what happened was that when we use the modified and compare it to the unmodified system, we can see that the rate, all the rate is going to be those that having a higher ohmic resistance. So we have separate the over potentials on the fuel crossover, activation, ohmic and concentration, and see which part of those stages that creates higher in potentials for the system. So for the first month, the rate goes to the most of the rates goes to the unmodified Microbiofuel Cell system, but the modified, which is modified with the aryl diazonium, showed much more over potential in the concentration. This is well understood because the modification actually invites and increase the adhesion of the bacteria onto the anode. So when there's a lot more bacteria and having dense bacteria created biofilm on the anode, then the concentration over there going to be much more than the one that's unmodified anode. And on the second month, when we start to immobilize the bacteria on the anode, it can be seen the situation is a bit different, where the treatment anode suffers more resistance on the ohmic and the concentration. Okay, the ohmic will be the movement of the ions in the electrolyte to the electrode. So you can see that once the bacteria has been encapsulated, it restricted the movement of ion onto the anode itself. So on the third month, when using the immobilization of anode, you can see that quite a number of overpotentials has been experienced by the treatment anode, the treated anode, which is immobilized. Okay, when we make a graph to see between the first, second, and third months for both the modified immobilized and the modified second control, both the modified and the control, the second control, shows the same behavior on the concentration loss. Okay, the concentration loss will be the feed, the source of food that they have. It seems to be from the first one and second month, the source of food, the critical source of food they experience increased, but after the second month to the third month, it loosened down. it relaxes down. It might be because that maybe because of the death of the some of the bacteria inside the reactor, maybe that since the reactor becomes more and more anaerobic, maybe some of the bacteria that could not be in that anaerobic environment died, so the food becomes again better for the electrochemical bacteria system. But for the rest, it seems to be the same, almost the same. However, jotted down here for both systems, the one that's red, the polarization, the overpotential that seems to be very affected to the system comes from the ohmic loss and the concentration loss. Okay, the summary here is for the Microbiofuel cell with a modified aerodisonium anode. In the first month, the Microbiofuel cell modified anode reduced about 90% in system overpotential compared to the unmodified. So during the first month of having the modified anode working in operation, the overpotential is about close to 20% lesser than the one that's not been modified. The strong bonding formed between the positive charge surface of the modified anode and the negative charge bacteria could have been the reason why it reduced the activation and ohmic losses. The concentration loss, however, was experienced higher in the Microbiofuel cell modified anode could be due to the dense biofilm achieved at the modified anode. So, on the second month, when we start to look at the effect on the immobilized anode in the Microbiofuel cell reactor, we managed to get this observation where, on the second month of operation, Microbiofuel cell immobilized anode had about 67% more overpotential in system compared to the modified anode. Huge overpotential came from the ohmic and concentration losses. This one here. This occurrence could be contributed to the sudden encapsulation of bacterial mass, okay, because the anode itself already has a very good attachment of bacteria, and then we encapsulate to immobilize the bacteria using the gel. So because of that, it might be one of the reasons that creates to the overpotentials. It restricted the movement, the ion movement into the electrode and limiting the food supply to the immobilized bacterial colonies. That might be one of the reasons. And as for the third month, shows systems started to acclimatize to the immobilization environment. Okay, there's a possibility that if we have it longer than 3 months, it will be nice to know what happened to the system. As for the internal resistance analysis, on the first month, the ohmic resistance of the system itself is lower on the MFC modified anode compared to the non-modified anode. After the second month, when the immobilization was introduced, the ohmic resistance is still lower on the treated anode compared to the non-treated anode. However, on the third month, seems to have a shift in direction where the immobilized Microbiofuel cell anode shows about 30% higher in ohmic resistance compared to the second control. Have to bear in mind here, the second control is the anode which is modified without immobilization. Okay, electrochemical results supports electrochemical analysis results. Microbiofuel cell immobilized anode started to increase in ohmic resistance as time goes by. This could be due to the constraint that occurs within the encapsulated microbial colonies. For the pH and the COD, there's not much difference between both, and however, we can see here that for the immobilized anode, the chemical oxygen demand had been reduced is much more than the Microbiofuel cell system that has modified anode without immobilization. As for the Coulombic efficiency, the immobilization of electrochemical biofilm had increased slightly the Coulombic efficiency of the system. Maybe because we have managed to entrap the good electrochemical bacteria inside the anode. For the morphology and element on surface, we can see that the modification was a success, since there's a extra elements that's been added to the system. As for the 1 month, okay, this is the one comparison between the modified, the bristles, okay, the morphology on the bristles between the modified and the unmodified. Okay, when you modify, you can see there's a lot more bacteria that attach to the bristles, and this is the immobilized. When you immobilize, you can also see here that's much more dense in bacteria and compared to the modified unimmobilized. Okay, so for conclusion here, immobilization seems able to increase our performance on the first 1 month of operation before it gradually reduced. Immobilization is hindered by both the ohmic losses and concentration losses. Other measures need to be considered if immobilization is to be applied. COD was able to reduce by the non-electrochemical microorganism in the reactor. Aryl modified anode showed quite reliable performance during the study. And lastly, both the Microbiofuel Cell modified anode, which is the second control, and the Microbial Cell immobilized anode showed reduction in system ohmic resistance as experiment continued longer than 3 months. So with that, I thank you and welcome valuable questions from the floor. For this one here, just an advertisement from my side. And end of October this year, we're going to have a symposium conducted by the Biofuel. You can register by scanning through here. And also, next week, we're going to have a free webinar by our adjunct professor from Petronas. So you can register by having scanned the QR code here. With that, I thank you for listening.
Thank you, Dr. Mi. Very nice presentations.
Dr. Yusliza?
Yes.
Dr. Yusliza? Sorry, there's a bit more I've forgotten to thank.
Okay.
I would like I would like to thank the funder, which is the UKM, University Kebangsaan Malaysia, through the grant of GUP 2018-012. Yeah, thank you.
Thank you. Thank you, Dr. Mimi.
You're welcome.
So now we come to the Q&A. So any question from our audience, you can type in the chat box. We have Prof. Asad. Anybody who's doing the same in microbial cell? Okay, because this is not my field, but can you explain to me how is the microbial MFC work in the application? For me, as the in the layman terms, how this?
Application means in the real world, how it can. Okay. So for the time being, the most famous biofuel cell is the microbiofuel cell. Microbiofuel cell works by producing electricity and also at the same time cleaning the organic liquids that become the fuel into the system. So how it works is actually the system itself, the general form of microbiofuel cell is a dual chamber microbiofuel cell, where the anode side is the place where they put all the bacteria inside and the waste. Sometimes they put pomade, like Mr. Teguh had explained just now. Sometimes we put pomade inside there, and we also put waste water inside there, or whatever liquid that has a lot of organic waste inside the anode section. So once we have that, at the cathode section, we're normally going to have oxidation that occurs there. The most cheapest going to be bubbling it with air. Okay, so by having bubbling air on the cathode side and the working of organics matters and microorganisms on the anode side, we combine it together by using an external wire and resistors. We're going to produce electricity from it. At the same time, if we withdraw the organic water out, we're going to see a reduction in the chemical oxygen demand from the analyte, the liquid that goes into the anode itself. So we can use it at the. Yes, sorry. Okay, so at the moment, the best usage for the microbiofuel cell will be in the wastewater treatment field, not so much in the electricity field, because we have yet to do more research in how to increase the electricity for this particular technology.
Oh, so more to the wastewater treatment. Then how you can, and in the stage, how you can ensure how clean is the water waste after this electrochemical?
If you remember in my slide just now, we measured the chemical oxygen demand. So we're going to measure the chemical oxygen demand of the input fuel into the anode side, and then we measure it monthly or weekly. It depends on when you're going to discharge the effluent to the outside world. So when you do that, you're going to measure the COD. If the COD is too high, then you will not be able to discharge it. And normally, like us, the Department of Environment in Malaysia, they already allocated what COD and BOD that's suitable for the discharge of water into water bodies.
So among all type of water pollutants, which one does it target?
It can target any organic water as long as the chemical oxygen demand is not more than 5,000. If it's too much, then it's going to have problem. Then the microbiofuel cell will not be that efficient. And if it's too thick, means there's the pomade, you can dissolve it, or you can have it straight away from the pomade industries. If you take it straight away from the pomade industry, it's going to be very too thick with grease. So that's going to be impossible for us to have it flow into the system. Therefore, normally the pomade that we use, we're going to dissolve it until it reduces in its COD numbers.
Okay. So this yet it has not started being implied, right?
In the European countries, they have started to use it. However, it's not yet commercialized.
I see. Okay.
Commercialized for STEM purpose, yes. For the education of students, yes, but for the industries, big time, not yet.
Okay.
Mm-hmm.
Thank you.
Welcome.
Okay, thank you. I think there's also just automatically reply to question from Suzaini. The question is microorganism based fuel cell is commercialized. I think you already replied that. Okay. So
yes.
Anything else? I think.
But the best part about this microbiofuel cell, suddenly I'm promoting microbiofuel cell. It's basically it's supposed to be a cheap technology because you can get it just from the dumpsters. It's very cheap. Okay.
Okay, thank you. Thank you. So now we can come to the next presentation. The next presenter is again Dr. Mimi, but with topic. She was presenting on the mitigating membrane Biofuel cell system in a review. Then without further ado, we invite Dr. Mimi again to give her presentation.
Assalamualaikum and hi everyone. For those who just dropped by, I'm Mimi Hani from Institute of Cellfield, University Kebangsaan Malaysia. And over that side is our QR code. If you scan, it's going to bring you straight to our Biofuel Cell group website. Again, I'm going to be presenting to you the work from our student, a master student, Madam Noiman Syafiqah Muhammad Nasruddin, on her work to mitigate the biofouling formation on the biofuel cell. So the aim of this talk will be sharing with you the gathered information on how other industries that face similar problem of biofouling, how the method that they use to reduce the effect of the biofouling in their technology. For introduction, okay, I believe that most of us have heard about the fuel cell, the chemical fuel cell, especially with the launch of Toyota Mirai, and also closer to home going to be the Sarawak Energy Bus. As you know, the fuel cell, chemical fuel cell runs 99% almost pure hydrogen at the anode system. The working temperature is about 60 to 100 degrees Celsius, although the electrical efficiency is not that high, about not until 100 degrees Celsius. However, because of its clean energy that it can give, no emission of carbon dioxide, no emission of carbon monoxide. Therefore, most countries around the world are trying to have the fuel cell on board, the hydrogen technology on board, so everyone can try to save the earth. Okay, the family of the fuel cell, the chemical fuel cell, we're going to be the biofuel cell. Biofuel cell, as the name goes, it actually go with microorganism and organic. Okay, organic is going to be the fuel replacing the hydrogen. Okay, if you have watched a long time ago the Back to the Future story movie where Dr. Emmett Brown pushed in waste, okay, from the rubbish bin, waste into the car fuel inlet. Same goes here, only that the waste has to be liquidy, okay, and most of the time it's going to be organic. And the catalyst, if it's for hydrogen fuel cell, it uses chemical catalyst, but for biofuel cell, it uses microorganism, bacteria, algae. So microorganism that can work well, we're going to use it as our catalyst. Theoretically, biofuel cell can produce up to 100% of efficiency. However, due to overpotentials that occurs in the system, we often get efficiency between 3 to 72%. However, the waste removal, which is the reducing of the carbon chemical oxygen demand, is high, almost close to 100%. And the power output can be generated at the moment about 3,600 watt per meter cube. Okay, biofouling mechanism. What's the problem with it? Okay, as you've seen just now, at the biofuel cell, I did mention that biofilm is supposed to occur at the anode and the cathode. Rarely we would like to have biofilm on the membrane. When the biofilm occurs on the membrane, it will create biofouling. So what's the definition of biofouling? It's actually the build-up of organism, microorganism, such as bacteria, fungi, and algae on a dam surface. For us, industries, technologies, we do not like to have the biofouling. The biofilm that creates biofouling, we don't want that. However, for the biofilm, it's actually their source of protection, like the fence of their house. They're going to build it so that they are safe from whatever chemicals that are going to disrupt their survival. The image here shows you the biofilm life cycle. At the moment, they identified about 5 stages. The first stage, where the bacteria first going to find the contact with the surface, and second, the bacteria are going to start to excrete its EPS, okay, the excretion solution that they have, so that they're going to become stuck very firmly on the surface. And the third, when they feel secure, the condition is good, they can start to grow the microcolonies. And then for the fourth stage, they're going to start to grow and grow and grow big and start to produce waste inside the biofilm. And this will not be comfortable for them, because this physiochemical, psychochemical of the environment going to change. Because of that, they're going to start to digest the matrix that they built, and going to free themselves to find another place for home. For biofuel cell, there have been 3 reported issues on biofouling. This includes for the microbiofuel cell, the microbial electrolysis cell, and the microbial desalination cell. The microbiofuel cell, for those who still are not yet familiar, is a technology that can produce electric while cleaning the wastewater, while the microbial electrolysis cell, it can generate energy by creating hydrogen or methane. And as for microbial desalination cell, it creates electricity while at the same time desalinate the seawater or highly saline water. Okay, the reported issues gathered from biofuel cell technologies on biofouling will be more on the effect that the thickness that the thickness that it can develop, and how it starts to affect the performance of the biofuel cell. Like for the microbiofuel cell, the significant declination of the power performance can be seen after the 6 months. For microbial desalination cell, they noticed that the biofouling occurs on the AEM site, which they locate the bacteria, the microorganism there. And for the microbial electrolysis cell, they discovered that it increased the internal resistance of the system. While having that, then they're going to have less hydrogen and less methane produced in the system. For biofuel cell, there are several membranes that we used for the system. The most favorite are the commercials, like the Nafion proton exchange membrane and the anion exchange membrane, because they are so expensive, and because biofuel cell do not meet the criteria that this commercial membrane can provide, such as can tolerate high temperatures, 60 degrees Celsius and above. Therefore, we move on to much cheaper version of membrane, such as the ceramic membrane. The morphology images here shows how the look of the membrane once it's been polluted with the biofouling. Okay, effect on the biofuel cell. Okay, there are several that have been cited. Like for the proton exchange membrane, it mentioned that the long-term effects of proton exchange membrane is going to reduce the performance. As I mentioned earlier, the proton exchange membrane and other commercial membranes are very expensive. Because of the biofouling, you have to change the proton exchange membrane to a new one, and it's going to incur cost. Okay, other than that, because of the internal resistance that has been reported, it's going to reduce the power performance. It can be reduced up till 100%. This is when they cited about significant effect in power performance after 6 months of continuous operation. The same goes with the anion exchange membrane, it deteriorates. However, the ceramic replacement of the expensive commercial membranes also affected by the biofouling. But the best part of the ceramic is it can be cleaned. It can be cleaned and then reused again, and it's cheaper than the commercial membrane. So now we're going to go to the site where we're going to discuss about the recent advancement we're going to see the recent advancement in biofouling prevention. We're going to go to 3 categories. the biofouling that happens in membrane biofuel cell, in other systems membrane, and on the surface in other system. Let's go to the biofuel cell first. For the microbial electrolysis cell, there's several studies done on polydopamine, PDA, okay, with silver nanoparticle. It says here that by doping the proton exchange membrane with silver nanoparticle and polydopamine, it managed to reduce up to 60%, 68% by increasing our performance. Okay, from here you can see that they've tried 3 ways. First with the silver nanoparticle, later with just the PDA, which is the polydopamine, and then they combine both. With the silver nanoparticle, it managed to kill the bacteria that wants to make biofilm on the surface. However, later it's going to leach out. The chemical, the silver nanoparticle, going to leach out into the solution. But what about the polydopamine? The polydopamine, it will attract the bacteria, but will not kill it. Therefore, when they combine the silver and the polydopamine together, it managed to work well, which is it going to attract the bacteria onto the surface and going to kill the bacteria. At the same time, will not have it to leach out. Okay, what about the biofuel cell? Biofuel cell mentioned about also using the silver nanoparticle. Okay, silver nanoparticle. And this is about doping the barium on the microbiofuel cell, doping barium cerium gadolinium oxides powders with cobalt and sintered to become ceramic surface. Okay, this is when they use the ceramic surface, but they have the barium together and mold it into a ceramic surface. 5% of the cobalt seems to be able to reduce biofilm very well. Okay. The best part about the ceramic is that you can mold it in whatever form you want, and you can add in whatever ingredients you want, and that's it. Rather than we highly dependent on the commercial, we can produce it ourselves. And for the microbiofuel cell that happened in the cathode, this is what they saw the biofouling that happened in the cathode. What they did was that they washing the biofuel cathode surface with 60% heated alkalilysis. Okay, this is more like doing chemical cleaning onto the cathode, and with that they managed to get rid of about 100% of biofilm on the surface itself. Okay, what about on other systems? On other systems, we look through several, such as the membrane bioreactors. For the MBRs, the MBRs, what happened is that they apply mobile entrapping elements. They use here the cell entrapping beads and microcapsules for methods in quorum quenching to disrupt the quorum sensing of the bacteria. Okay, when they disrupt it, then they're going to destroy the bacteria, eventually the biofouling. What about the reverse osmosis membrane? In the reverse osmosis membrane, they applied the 4-nitropyridine N-oxide as quorum sensing inhibitors. So basically for the MBRs and osmosis membrane, they destroy the quorum sensing of the bacteria. In the medical field, what happened, they use the isoporous silica micelle membrane on indium tin oxide glass using modified Stover method as electrode. From here, the produced electrode provides anti-biofouling layer for electrochemical detection of drug molecules in human blood without the blood have to go for pre-treatment first. Okay. For wastewater filtration, they modify hollow fiber polyether sulfone with silver ions. Continuous 8 hours filtration should modify membrane made from hollow fiber polyether sulfone with silver ion solution had 15% higher permeability. When there's a higher permeability, means the biofouling already been evacuated. Continuation from the membrane in other system. Now we look at the continuous cross-flow membrane module. in here, they applied the silver nanoparticle impregnation on sulfonate polyether sulfone. Before this, we saw the silver nanoparticle polydopamine on protein exchange membrane. This one, they applied on sulfonate polyether sulfone space. Results showed complete E. coli cell killing E. coli flowing contaminated water. And on bioreactor membrane, what happened? Grafting quaternary ammonium compounds on polyvinylidene fluoride membrane. Okay, from here you can see the one without the QAC and with the QAC. With the QAC, you can see that the normalized flux is higher rather than the non-treated ones. Okay. Continuation for membrane and other system. And bioreactor membrane, study 2, modifying the PVDF membrane with QAC and silica nanopollen. Modification showed similar reduction to the microorganism. 98% to 100% of the microorganism died. And as for the forward osmosis, using thin film composite membrane with graphene oxide, it managed to kill up to 80% of the microorganism. Okay, what about surfaces? Okay, this just now was membrane, now just purely surfaces. What happened? There's a study done on fishing net where they applied zinc oxide covering the fishing net surface, and from there they managed to reduce 30% of biofouling compared to the unmodified control. Okay, uranium recovery. For the purpose, they use silver ions doped with zeolitic imidazolate framework on a ketosine graphene oxide foam substrate. From here, they managed to get more than 70% biofouling reduction in seawater environment. And as for paint and coating, titanium oxide applied to surface, and they managed to have the surface freed from bacteria. This is actually surfaces that's prone to the flooding condition. So as for conclusion, biofouling is unavoidable. Okay, however, highly hydrophilic smooth surfaces can reduce bacterial adhesion to form biofilm. Manual cleaning can restore back the performance, however, it's time-consuming and costly. There are studies using chemical solutions such as silver and quaternary ammonium compounds show almost 100% of biofouling elimination. However, this study was done on certain culture of microorganism, so have not yet tried on other kind of microorganism. Therefore, for further studies, need to be done to find suitable anti-biofouling substance or mechanism which can be applied to biofuel cell system for a long-term continuous operation. And before I end, again, I would like to invite you to our symposium. And with that, I thank you and I welcome any questions that you'd like to ask me. Thank you.
Okay, thank you, Dr. Mimi, for a very nice presentation.
Welcome, Dr. Yusufa.
You're welcome.
Sorry,
Unfortunately,
just like just now I've forgotten, I just like to thank the funder, Ministry of Education Malaysia, on the grant FRGS 1 2018 TK10 UKN 032. Thank you so much. I forgot just now.
Okay, thank you. However, since we already limit the time schedule, so I think maybe we should skip Q&A, but I advise maybe Dr. Mimi can add your contact number or your email to chat box so any audience can ask the question later.
Will do. Thank you so much.
Okay, sorry, Dr. Mimi. Okay, now we move along to the next presentation. Is from our invited speaker, Dr. Yasmin Abdul Wahab. She's a senior lecturer from the Nanotechnology and Catalysis Research Center, NanoCat, University Malaya. Okay, please welcome her. The floor is yours, Doctor.
Thank you, Dr. Liza. So I'm sharing my screen. Are you able to see it? Can you see my slides?
Yes, doctor, it's visible.
All right. Okay, thank you, Miss Afrin. Okay. Assalamualaikum and a very good evening to everyone. My name is Yasmin Abdul Wahab from Nanotechnology and Catalysis Research Center, NanoCat, University Malaya. I'm honored to be an invited speaker for this parallel session 3, cluster 4 in MICNC 2021 conference, and also honored to be to such an invitation, and also will try my level best to enlighten the research sharing event. So without further ado, I would like to share the research work on optimization of cobalt nanoparticles for biogas enhancement from green algae using response surface methodology. And also, I would like to credit Prof. Dr. Hassad, A. Zaidi, Mr. Soib Zaid Khan, and Mr. Muhammad Nihal Nasir and Muhammad Asif from NUST, Pakistan for their contributions on this work. So first and foremost, I would like to explain on the research problem and objective. So the process, so as was seen here, the disposal of algae waste has become a very great problem those days. So in this case, algae will become a potential organic waste for the productions of biogas and biohydrogen. So in this process of ship ballast water treatment and algae disaster management has produced a large amount of algae waste, which is become a major problem in the field of marine environmental protections. So this algae waste has been a great potential to become a raw material for biogas productions, as well as comprehend multiple benefits for the waste treatment and resource utilizations. So in order to increase the productivity as well as the characteristics of algae waste, so the study has focused on introducing the cobalt nanoparticles in the anaerobic digestions, in short we call as the AD, for green algae anthropomorpha. So to continue with, we know that in the recent development, the nanotechnology has been fast growing techniques. So most of the previous researchers have shown that the nanomaterials can be used for the purpose of feedback modifications. And this is particularly in AD nutritions, which is the forms of nanoparticles or nanomaterials might increase the effect towards all the biogas enhancements. So to further continue, the performance of AD process is normally is highly dependent on the concentrations of the dosage of nutrients which has been introduced. So in most cases, we might see the high concentrations of nanoparticles will be resulting in the biogas inhibitions, whereas the low concentrations will actually favors the AD process, which is the anaerobic digestion process. So I will move towards the next slide, which will be describing the anaerobic digestion process. So here we might say the AD process is considered to be a common and valuable solution to process an organic waste and ferment it to produce methane and hydrogen. So in this AD process, the degradations as well as the transformations of the organic waste into hydrogen, methane, and as well as the carbon dioxide, various anaerobic microorganisms might be utilized. So, however, for their reproductions and growth, they themselves might need some essential nutrients. So this complex process normally comprises 3 stages, which is highlighted here: the stage of hydrolysis, stage of acid formations, and thirdly is the stage for methane formations. So the very first stage is the stage of hydrolysis. So in this process, the simple soluble monomers or dimers are being produced by decomposing the complex insoluble macromolecular organic aggregates. Meanwhile, the second phase will be on the fermentation stage, and this conversion process will actually have a small molecule products of the hydrolysis process into a volatile fatty acids as well as the nutrients with the actions of microorganisms. So next is the hydrogen and acetic acid acetic acid production stage, whereas is might be say has a far most complex one. So in this stage, we might say that these actions of microorganisms for the productions on the products of fermentations stage, as well as alcohol, volatile fatty acids, and lactic acids, and etc. So in the metagenesis, which is the third stage, there exist two methods of methane production, which involving the utilizations of various activities on microbial groups. So thus the form methane, which will be significantly varied in the quality. This is actually dependent on few factors such as biomass compositions, the additive, as well as the selections of the conversion process, and last but not least is the precursors. So moving forward will be some example, will be the practical applications of the study into the large scale plants which has been employed for this purpose. And then we can see here, there are some literature review or studies which has been conducted to make sure that we have the novelty selections of nanoparticles, which is the cobalt nanoparticles. And from this slide, we can see only one study has been conducted by Abdul Salam, which is this one, the cobalt. So it has been conducted by him utilizing the cobalt nanoparticles with the carbonium waste, and also resulted in the enhanced of biogas productions. Therefore, this study actually focused on using these cobalt nanoparticles with green algae waste. So to move forward, I will just roughly show you the graphical abstract, where we have the anaerobic sludge from wastewater treatment plant and with the green algae Andromorpha, and followed by the process of AD with the batch anaerobic digestions with 500 ml with the temperature within the 37 Celsius degree with the 37 degrees with the mixing speed of 150 RPM, and also with the time range of 168 hours. So we make sure that the nanoparticles, the cobalt nanoparticles, is within the less than 100 nanometer for the productions of biogas. So move forward is the materials and methods. I would like to highlight the raw materials, which has been a significant materials that has been used for this purpose. So the first item will be on the anaerobic sludge, where this anaerobic sludge has been acquired from the anaerobic anoxic oxide AAO reactor at Harbin Wencheng sewage treatment plant in Harbin, China. Meanwhile, for the green algae, the Andromorpha we acquire from the Institute of Hydrobiology of the Chinese Academy of Science, Wuhan, China. And lastly is the cobalt nanoparticles, which has been purchased from China Metallurgical Research Institute, Beijing, with the average size of less than 100 nanometer. And moving forward is the experimental procedure, where we conduct these experiments with an anaerobic batch system with the glass lab scale bottles with a working volume of 500 ml, which has been used as a biodigesters. So these bottles were actually filled, used as a biogas. These bottles has been filled with 60 ml sludge and 20 gram of Andromorpha to initiate the AD process. The nitrogen gas was purged into the bottles for the 300 seconds. So the digesters were also sealed with the rubber stoppers, purging into the nitrogen gas, and also to create the anaerobic conditions, which has been maintained at the temperature of 37 with the mixing speed of 150 RPM. So you can see here, these are the experimental setup. So the photos has been we demonstrated the photos of anaerobic digesters, nitrogen purging, and thermostat steam bed vibrator. And for the response surface methodology, which is the tool which has been used to improve and optimizing the unknown systems or the process with the combinations of two methods of mathematical modeling as well as the statistical analysis. So throughout this method, has been used then experimental design, which is used to effectively respond on the surface design and statistical model by establishing a fitting curve between the experimental design and the modeling data. So the scientific map here actually will be demonstrated later on in the results part, where it will actually describes the relationship between the response as well as the variable. And lastly is the three-factor CCD, which has been used to design the experiment for constructing the models using Design Expert software. So as for these mathematical kinetic models, there are two types of models which has been used here. The first model equation is actually represent the modified compass model, and the second one is for the logistic function model. So those models actually has been used for the biogas prediction as well as estimating the kinetic parameters, which has been shown here in below equations and parameters. And as for the AIC, which is represent for the high key information criteria, is actually used to compare both models, which is the modified compass models as well as the logistic function model. So we're going to find out, so the AIC can be used to find out which model out of these two will be better for green algae anaerobic digestions, the AD, when we enucleated with the cobalt nanoparticles. As for the next slide, it shows the optimization stage of cobalt nanoparticles concentrations, where we used the level of independent variables. There are three independent variables at this moment for this study. That is the temperature, the initial pH, and as well as the cobalt nanoparticles concentrations, where we have it shows with the low level to the high level of optimizations value. And move forward is the optimizations which has been run in the modeling software, where we have the iterative run into 15, and we can see here the design of experiments actually shows here the corresponding experimental results between all the independent variables, independent parameters. And move towards the results, I will highlight based on the optimizations which has been done based on the two models, the modified compass model as well as the logistic model. We acquire a contour plots, all right, and also the response surfaces for the effect of initial pH, as well as the cobalt nanoparticles concentrations with the 3D plots. So if you can see here, this is 3D color. This is the color code in the figure is actually describing you the range of the biogas which has been produced. So with the red, you can see as will be actually conclude has the highest productions of the biogas. So the curvature of these figures actually depicts how the selected parameters will change the biogas production. And move towards the next result will be the contour plots and response surfaces with the effect of temperature as well as the initial pH 3D plots. And next one also will be shows you the contour plots and response surfaces with the effect of cobalt nanoparticles concentrations with the temperature 3D plots. Now, based on the optimizations of the metallic nanoparticles concentrations, the following regression model has been suggested to best fit our data for the cumulative biogas productions, and followed by the Anova results. So as for the Anova results, we can see here is a mathematical regressions model which has been shown here, all right? And from these results of the Anova test, it is revealed that the value of R2, which is the coefficients of the determinations, is 0.8294, which is near to 1.00, and it actually validates the mathematical regressions model. The value of p-value here, okay, for cobalt nanoparticles is 0.0, that which implies that there is a strong correlations between the input parameters as well as the biogas productions. So therefore, we can infer that studying the impact of input parameters on biogas productions is on the cobalt nanoparticles concentrations. Impact of different concentrations of the cobalt nanoparticles is depicted in this figure. And the observations shows here that the additions of cobalt nanoparticles has a positive effect, okay, on the biogas productions. And the fact that all the samples with the cobalt nanoparticles have a high positions in the graph. You can see here high positions in the graph compared to the control, or we might say the baseline data, which validates the enhancement in a biogas production. So in this case of green algae, there will be a two cell layers, which is namely the external and internal layers. So the reactions of these algae with the cobalt nanoparticles, the external layer is actually polymer matrix consisting the carbohydrates as well as the proteins, whereas the internal layer will be made up by cellulose. So these cobalt nanoparticles will actually first solubilize the external layer and followed by the dissolutions of internal layer, that which will increase the overall lysis rate. So ultimately, it will be increase the biogas productions. So our results actually have a good increment with the ones produced by Abdul Salam et al. In the previous slide that has been showed to you for literature. Moving to the modified compost model. So these are the curve fitting that has been done by modified compost model with the different concentrations of cobalt nanoparticles. And as for these parameters of modified compost model, we can see here this slide is actually showing you the parameters of for modified compost model which are fitting the real experimental data. So the values of kinetic parameters and differences between the measured biogas yield as well as the predicted biogas yield is actually presented here for the different concentrations of cobalt nanoparticles between the range of 2 milligram, 1.51 and 0.5. And also the MBPR, which is represent the maximum gas productions. We can see the readings of the value will be from 5.35, 5.53, 4.72, and as for cobalt nanoparticles with concentrations of 1 milligram, it represents 6.039 mbpr and 6.38 mbpr for 0.5 concentrations. Now moving towards is the slide to show the curve fitting for the logistic function model. As for these parameters of logistic function model, is again showing the parameters with the fitting with the experimental data, and the values of kinetic parameters as well as the difference between measured and predicted biogas will actually yield at presented here for different concentrations of cobalt nanoparticles. Meanwhile, the readings or the parameter or MBPR for the cobalt nanoparticles with different types of different concentrations as shown here with the readings of 5.53, 5.75, 4.99, 6.56, and 6.87. So the correlation coefficients of the modified compost models here, as well as the logistic function model, were above 99.04% as well as 98.67% respectively. Now, move forward is the AIC test, which is the Hierarchy Information Criterion test. So in this slide, it actually represents the AIC test results in table, which is can show here. You can see the difference in yield between the measured and predicted models, which is lower for the modified compost model, which is 81.78818, compared to the logistic function models, which is carry out the values of 6.04301. So it is AIC test is actually confirmed that this modified compost model has a lower AIC value and it can be considered as a better choice. So as for the conclusions, the effect of cobalt nanoparticles on AD, anaerobic digestions of Enteromorpha algae was carried out in this study, and the optimizations done by using the RSM. So for the detailed experiment at optimized values shows that the optimized concentrations show enhancement in biogas yield, which represents the cobalt nanoparticles at the concentrations of 1 as well as 0.5. So the reaction kinetics here was performed by using the mathematical kinetic models. So the two models has been highlighted here, the modified compost model as well as the function model, which are fitted well with the experimental data. And as for the AIC test, which has been used to compare those models, both models, shows that the results of modified compost model has a more suitability to use in this case. And these studies actually lays a foundation for an improved biogas yield by cobalt nano enucleations in AD for green algae. As for further research, we will need to explore the reactions of mechanism by measuring various soluble indexes and analysis of translations change for the microbial communities due to the presence of cobalt nanoparticles, which resulted in enhanced biogas productions. So by that, I would like to end my presentations for this particular study. So that's all. Thank you.
Okay, thank you, Dr. Yasmin, for sharing very interesting topic. So now I would like to read question from the audience. So there is a question from AP Dr. Suresh Sagadevan. And particle size of cobalt nanoparticles, and what is the effect of temperature and pH on the size of cobalt nanoparticles?
Okay, all right. Thank you, Dr. Suresh, for your questions. First of all, on the size of cobalt nanoparticles, as I highlighted earlier, it should be within the range of less than 100 nanometers. Meanwhile, as for the effect of independent variables for the temperature, I might say that I will go back to my slides that so as for the temperature and initial pH, we have been used the optimizations value, which is the low level for the temperature we took up at 25 degrees. As for the high level, we have 45 degrees. And meanwhile, for the initial pH, we are at the range of 5 to 9 pH level. So, does that answer your question, Dr. Suresh? Hello?
Yeah, Dr. Suresh is not in the screen. I think this already answered his question. Dr. Yus?
Yeah, there's no reply from. Another question also from Afrin. How can nanoparticles to the AD process impact on biogas growth?
Okay, thank you, Ms. Afrin, for your questions. For these questions, a few studies has been reported with the effect of nanoparticles and nanomaterials on the modifications of the feedstock. So especially by introducing these nanoparticles to the AD process, which is the anaerobic digestion process, it's actually shown us a significant impact on biogas growth. So studies has revealed that with the additions of these which actually determine the concentrations of nutrients in the feedstock that has a direct impact on the productions of biogas. So by that, I will say that the high concentrations of nutrients will actually results in the inhibitions, while meanwhile, with the low or medium concentrations of nanomaterials or nanoparticles will actually resulting in the enhancements of biogas productions or biogas forming. So that's all.
Dr. Yasmin. So any audience from the floor, any question from the audience? Anybody want to ask in live? So no
No question.
no more question. Maybe Dr. Yasmin, you want to say something?
I want to add something. Okay, I just want to thank all the MICNC 2021 committee, IT committee, for giving me a chance to be an invited speaker at this session. It's really honored to be here and sharing my presentations regarding the cobalt nanoparticles for the optimizations in AD process. And also, I'm really thankful for the opportunity and I wish a very successful, I really wish well done to all the committees, CNC committees. And that's all. Thank you so much, Dr. Yus and everyone.
Yeah. Well, thank you very much, Dr. Yasmin. So I think, okay, now we move to our next speaker. Our next speaker is Mr. Muhammad Nihal Nasir from the National University of Science and Technology, Pakistan. His topic on the statistical modeling and of a two-chamber for biofuel cell by response surface methodology. Mr. Nihal, the floor.
Respected organizer, attendees and professors, Assalamu alaikum and good morning. Today I, Muhammad Nihal Nasir, researcher at National University of Sciences and Technology, Pakistan, will present the topic of my project, Statistical Modeling and Performance Optimization of a two-chamber microbial fuel cell by response surface methodology. My group members are as displayed. This project is supervised by Dr. Asad Ali Zaidi and done in collaboration with three well-renowned researchers, Dr. Yasmin Abdul Wahab, Dr. Johanna Jaffer, and Dr. Kingship Rutta. I will be taking you through the following scheme of the presentation, where I will start with the introduction of the microbial fuel cell, and while taking the presentation further, I will explain the methods and materials
this. I think somehow it got muted. Just a minute. So, may I know, was it totally not placed? Should I start from the beginning, Mr. Nihal?
Then you can start where it left.
Oh, you could hear it?
Yeah, you can start it from third slide.
Okay.
I will be taking you through the following scheme of the presentation, where I will start with the introduction of the microbial fuel cell, and while taking the presentation further, I will explain the methods and materials utilized to optimize microbial fuel cell, and finally, will draw a conclusion. With around many issues that the world is currently indulged in, microbial fuel cell is touted as a single solution to address four major global issues, that is, meeting water demand, energy demand, ensuring zero emission, and fossil fuel independence. Despite being such a useful technology, microbial fuel cells are still in labs and couldn't find industrial applications. Therefore, we conducted a deliberate literature review to find research gaps. With regard to this topic, we have found four potential research areas that were worth exploring. First, it was found that the mathematical modeling of microbial fuel cell lacks interest from the research community, and there is no substantial growth within this area. A few models are available, but researchers find it difficult to understand and use these models. Secondly, the integration of microbial fuel cells with other technologies is still a novelty. Thirdly, it was found out that the major issues faced is low power density and the use of expensive electrodes. It is main hindrance to microbial fuel cell applications in industrial sector. Lastly, there is a lag in optimization studies of microbial fuel cell. So during the course of this presentation, I will address last two research gaps, that is power density and optimization of microbial fuel cells. So the project scope here, we will move forward to optimize the performance of MFC, thereby employing a response surface methodology, and will validate our results in the last phase. The design inspiration of the microbial fuel cell model is drawn from literature from Zhang model. The dual-chamber microbial fuel cell was constructed with the specifications as displayed. Both anodic and cathodic chambers were constructed of equal volume. Both electrodes were made of graphite, and cathode was further coated with platinum. We used Nafion 117 membrane to separate both chambers. Moreover, the anode and cathode chambers were connected by using a platinum wire. Moving forward to MFC feed and its working conditions, a buffer solution was prepared using 4 millimolar sodium acetate in conjunction with acetic acid. pH was maintained at 7 by adding HCl or NaOH when needed. And with this, to maintain the anaerobic conditions in anodic chamber, nitrogen gas was purged in this chamber. The experiments were conducted at room temperature and at atmospheric pressure. Looking forward to the experimental design, the sensitivity analysis of some parameters of microbial fuel cell was conducted in a previous study by Zhang. Since MFC is currently unable to find its application in industrial sector owing to lower power density output, therefore, this study aimed at enhancing the MFC power density by optimizing 3 sensitive parameters using a response surface methodology. These 3 parameters are depicted in the table and are inspired by the study of Zhang. Maximum and minimum values of these three independent parameters along with the mean and standard deviation is depicted in the table. To calculate total number of experiments required, following equation was used. On the right hand side of the equation, the first term denotes number of factorial points, followed by the number of axial and central points respectively. For our case, the number of independent variables were 3, that is, the value of k will be equal to 3. So we used 20 set of experiments to optimize microbial fuel cell for present study. Here are the 20 experiments that were performed as suggested by the previous formula. The software used in this study was Design Expert. Moving forward towards the results and discussion, the following equation was derived representing the analytical function to predict the power density based on 3 selected control variables. The coefficients of A and B are high as compared to the coefficient of C, which indicates that the power density is highly influenced by the change in flow rate of fuel feed to the anode and the concentration of acetate in the anodic chamber as compared to the changes in the concentration of oxygen in cathode. Therefore, we can say that anodic chamber of microbial fuel cell is the main portion that need optimization. To check the validity and significance of the model, Anova basic criteria was used. We evaluated the value of R square, adjusted value of R square, adequate precision, and the difference between adjusted R square and predicted R square. The corresponding values are depicted in the table. While for a model to be significant, the values of both R square and adjusted R square must be close to 1. And since our case, the values lie within this domain, so the model is considered to be significant. The graphs represented here further validates the model. Figure A depicts the relation between actual and predicted values. Actual values are derived from the experiment and predicted values are obtained from the model that was presented in the last slides. There is a negligible amount of inaccuracy that exists between the practical and the predicted values. While the figure B shows that the study undertaken includes marginally insignificant instabilities, whereas the figure C shows that the point depicting unusual behavior are not significant and the output is almost stable. Hence, based on these figures, it can be concluded that the model is significant. Optimal conditions and optimal design points will be looked upon to interpret the results. The three-dimensional response surface helps in the visualization of the interaction between the independent variables and the output, that is, power density of microbial fuel cell. Figure here shows that the power density increases with the increase in oxygen concentration while keeping the fuel feed flow rate below a range that is 1.9 multiplied by 10 raised to power minus 3 meter cube per hour. The figure shown in this slide relates the effect of fuel feed flow rate and acetate concentration on power density. The trend suggests that the increment in acetate concentration has a significant effect on the power density. It can be realized that the maximum value of power density was attained increasing acetate concentration while keeping fuel feed flow rate at its minimum value. In terms of numbers, an acetate concentration of 2.6 mole per meter cube and fuel feed flow rate of 1.8 multiplied by 10 raised to power minus 5 meter cube per hour was the main design point that was suggested from this figure. Furthermore, power density was found to be dependent on the increase in concentration of both parameters as shown in the figure. The highest value of power density was obtained at an acetate concentration of 2.6 mol per meter cube and an oxygen concentration of 1 mol per meter cube. Based on controls described in the last slides, optimal operating conditions were identified and are highlighted in the table. Fuel feeding rate is 0 for the optimal conditions. This implies that a steady state operation is recommended for microbial fuel cells, and the batch mode is the preferred mode for obtaining the highest power density. As far as the validation is concerned, it has been observed that the optimized microbial fuel cell, as per the parameters discussed earlier, produced much higher power density in comparison to the control MFC. The optimized microbial fuel cell had a power density of about 3.4 watt per meter square, while the density of the control microbial fuel cell was nearly 2 watt per meter square. Therefore, we can say that the microbial fuel cell is substantially optimized in this study. Concluding our presentation, I would re-emphasize the pointers discussed earlier briefly. We successfully utilized a response surface methodology to enhance the power density of microbial fuel cell. The statistical model was developed depicting the effect of 3 independent variables on power density, and the model was validated using Anova test. Lastly, using optimum conditions, a maximum power density of about 3.4 watt per meter square was produced. With respect to future prospects, effect of different electrode materials and membranes can be studied. In addition to that, sensitivity analysis of a wide range of parameters of microbial fuel cell can also be attractive for research community in future. Thanks.
Thank you, Mr. Muhammad Nihal Nasir, for sharing the interesting topic. So now I would like to open for the question and answer. Dear audience, you can put your question session tab, because sometimes I may overlook if it is in the event tab.
Yes, Doctor. Now there is a question from Dr. Yasmin. Mr. Nihal, sorry. She answered the question.
Okay, there is one from Dr. Hani. Thank you, Dr. Nihal. I was interested in the modeling because of myself not well versed to it. So the data was taken for how long duration of the operation?
Sorry, am I audible now? Thank you, doctor, for your question. Basically, for this present study, we collected data for about more than 2 weeks, because it was a part of the thesis, and we have limited time to collect all the data and conduct a complete analysis. So we collected data for about 2 weeks, and based on data analysis and data normalization, we extracted all these results.
Okay, thank you. There is another question, again from Dr. Mimi. Did you also consider on bacterial growth in the system through time?
Basically, in this project, we didn't much focus toward the bacterial growth, or like we didn't covered microbial fuel cell with the perspective of biology, including bacterial growth or biofouling, etc. We mainly focused on increasing power density, and we mainly discussed three factors in this complete experiment, that uh, related to fuel feed flow rate and the concentration of acetate and the concentration of oxygen. Is there any other question?
Dr.
Any question from Hafrin? There's no question, right?
No.
Oh. So thank you for the topic. Maybe Mr. Muhammadnya have something to add before we end.
No, that's all. I would just like to thank MICNC committee for providing me this opportunity to present my findings. Thank you.
So now we reach at the end of the session. I would like to thank all the audience presenters for your active presentation, for the active participation today. On behalf of the MICNC committee, I would like to seek your kind cooperation to fill up the feedback form as given by the box. Is it here? Can you Afrin, is it already in the chat box? Yeah, please kindly fill up the form. Now, announce for the best presenter. And I would like to announce the best presenter for this session goes to Dr. Mimi. This for her topic. Wow, welcome. So congratulations to Dr. Mimi. So now I would like to invite all of you to join the rest of the event because this session already end. Oh, but before that, sorry, I forgot. I would like to take photo session with the all presenter and audience before we end the session. So I would like to everyone to open your camera. Any audience? Maybe you can ask for sharing so we can take photos together. Okay. Maybe only this. Okay. Aflin, in count of 3, 2, 1, smile. Okay, thank you. Okay, thank you. And I hope to see all of you again tomorrow on the tomorrow events. Okay, see you. Take care.
Thank you, Dr. Yus. Thank you, everyone.
Thank you.
Okay, finished.
Afraid.
What happened?
Nothing lah, Afrin. I always lost idea. I lost my mind.
It's okay. It was so long already.
So we finish on time?
Yeah.
We finish on time. Okay lah.
Okay. So just put
Okay.
the message that we finished.
Okay. Thank you very much.
Thank you. No, we were going to do a blunder if did not notice that your deck marks is missing.
Yeah, I really overlooked and that part.
No problem, no problem. We are for that. We are for that. Rely. Okay, thank you.
See you.
Bye.
Bye. Thank you. Goodbye.